So I pre-calculated here a little bit for you so I don't have to take too much of your time to start with. So potential energy is mgh, kinetic energy is 1/2 mv squared. So kinetic energy is 1/2 mv squared. And I calculated how much potential energy the object has all the way on the top, all the way right here, and how much kinetic energy, because before the object is dropped, it doesn't have any kinetic energy. Initial velocity is 0. Because initial velocity is 0, initial kinetic energy is also 0. And the potential energy, the one that we calculate, it's the mass times g times h, and h is 125 meters, so it looks like there is 5,000 potential energy joules. And the total mechanical energy is the sum of both. So the total mechanical energy is 5,000 joules. So no matter where we looked at our problem, we're always going to have 5,000 joules of total energy. So when the object is moving at 30 meters per second, so at this point, when the object is moving at 30 meters per second, I want to calculate at what height the object is and how much energy it has. So at first I'm going to start, because it has a velocity, so I'm going to start with the kinetic energy. So the kinetic energy is 1/2, the mass is 4, and the velocity squared, that's 30 squared. So it looks like 2 times 900, so that is 1,800 of joules. That's how much kinetic energy. The total energy must be 5,000 joules. So the total energy, let me see if I can make these highlights here. Maybe not. So the total energy is 5,000 joules. So it doesn't matter where I look again, it's going to be 5,000 joules. So my potential energy with the kinetic energy must be equal to 5,000 joules. So that means my potential energy is 3,200 joules to give me 5,000 joules of energy total. And because I know how much potential energy is equal to, and I know its formula is mgh, I can plug in the numbers. So I have 3,200, 32,000, and I have 4 times g and times h, divided by 10 both sides, and then I can find that h is equal to 80 meters. So when the object is 80 meters above the ground, it's going to be moving at the velocity of 30 meters per second. So now I'm going to do similar calculations for when we are having potential energy of 3 kilojoules. So I'm going to go to the next page. And now we have 3 kilojoules of energy, potential energy at this point. So at this position, they give you that the potential energy is 3,000 joules. So that means the kinetic energy must be equal to 2,000 joules, because the total energy is still 5,000 joules. So again, my total energy has to stay conserved. It just will transfer from one type of energy to another. So it must be equal to 5,000 joules. So my kinetic energy together with potential energy always should give me 5,000 joules. My kinetic energy has a formula: 1/2 the mass, v squared, is equal to 2,000 joules. Then I have v squared is equal to 1,000 joules. And if I take the square root of that, I'm going to get 10 square roots of 10 meters per second. So that gives me the velocity at this height. Then I can also find the height, because the potential energy is mgh and equals to 3,000 joules. I can plug in the numbers, the mass, g, and h is equal to 3,000. So my h is equal to 75 meters. And the last one is right before it hits the ground. So here's the ground, and right before it hits the ground, or not even right before it hits the ground, it is still, it's the height of 10 meters above the ground. Okay, this is still 10 meters above the ground. So the potential energy at 10 meters is mass, G, and H. So I get the potential energy is equal to 400 joules. But the total energy, again, has to be equal to 5,000 joules. That gives me that my kinetic energy is 4,600 joules, right? 4,600 joules. So my kinetic energy is 4,600 joules, because the total energy needs to give me 5,000. So kinetic energy is 1/2 the mass, V squared, and equals to 4,600 joules. V squared is equal to 2,300, and V is equal to, if I take the square root of 100, gives me 10. Cannot take square root of 23 meters per second. And the final one is right before it hits the ground. Right before it hits the ground, the potential energy is going to be equal to 0, because there's going to be no height. The total energy of the system is 5,000 joules, so the kinetic energy must be equal to 5,000 joules, because the total energy together is 5,000 joules. Kinetic energy is 1/2 the mass, V squared, and equals to 5,000 joules. That gives me V squared is equal to 2,500, and V is equal to 50 meters per second. I wanted to show you how we used to solve this question without the energy. So I could calculate the distance it traveled when it reaches 30 meters per second. So the distance is average velocity times the time. In order to get to 30 meters per second, it would pass 3 seconds with acceleration due to gravity 10. So I have average velocity times 3 gives me 45 meters. So an object will fall down 45 meters before it reaches 30 meters per second. If it was originally at 125 meters, then minus 45 gives me 80 meters. So here is this one. Then let's do in this color as well. Now you were 10 meters above the ground. Let's do this one because that's the one we don't have to use energy to solve. So if you are 10 meters above the ground, so you have been moving the distance of 115 meters. So I can find the final velocity in this case as the square root of 2 acceleration and 115. So V final is equal to 2,300. V final is 10 square roots of 23 meters per second, which gives me exactly the same number as before. So there are different ways to solve the questions, and then using energy and conservation of energy, always knowing that the total energy does not change. The total energy stays the same. It's just the amount that kinetic or potential energy has in it is different and changing, but the total energy stays the same, so you can always solve for one or the other if you know one of them.